So today we are going to be solving this problem from HackerRank, that is from day one, and this problem is called Interquartile Range. From the start, when I tried to solve this problem, it was a bit confusing until I find out a very easy way to break it down. Now the problem says, if you are given an array, now just not an array, but this array is just a set of values and their frequencies. Now if I write something on the board, for instance, if you are given an array like this, AR is equal to 1, 2, 3, 4, 5, 6. If you are given an array like this, to find the interquartile range, what you are going to do first is to split this array into two, and then you are going to find the median of this side of the array, and then you are going to find the median of this side of the array, and then you are going to subtract the two. So basically, you are going to find here, you are going to find Q1, and then you are going to find here Q3. Now this is very easy, because what you are going to do first is to write a function that calculates the median. So if you write a function that calculates the median, then you can always slice your array and find the median of any portion of your array, right? So let's start with writing a function that calculates the median. So that function will go this way. Given a function, let's say I'm writing it in Python, def get median, and it takes an array, okay? So we have this function get median, it takes an array. The dimension of the array is not important for now. How do you calculate the median of this? What you are going to do is simply first get n to be the length of the array, and then calculating the median depends on whether the length is even or odd. If the length of the array is odd, then the median is going to be the number in the middle. Take for instance, you have this, the length of this array is even, so it's kind of a bit dicey. But assuming the length of this array is odd, let's say we have 6, then it means that the median of this array is going to be this number right here, right? What it means is that you don't have to worry, you simply return the number at position mid, right? But before I continue, let me warn you that this array must be sorted before you can calculate the median. So the first thing you want to do is to sort this array in place. So you're going to say something like arr.sort. So in Python, you can just sort this array in place like this, okay? Now, the next thing you want to do is to check if this length is even or odd. If the length is odd, simply return the number in the middle. Now, look at what happens here. If you have 0, 1, 2, 3, 4, 5, 6. Meanwhile, the length of this array is 7. So in this case, you're going to return the number at 1, 2, 3, 4. So the number at position 4, counting from 1. Now I'm going to calculate the median to be the length of this array, which is n, divided by, now this is very, very important, the length of this array divided by 2. Now this number here, which is a median, we want it to be an integer. So we are going to do integer division, and you are going to use this operator right here to do integer division. So if it's 3.5, is going to return 3. So basically, if this is 7, this is going to give us 3 and not 3.5. So that means that we have 0, 1, 2, 3, and that is going to give you the median of this array. So what it means is we are going to now check here if I think maybe I can move to this place, or maybe I can continue here. So if the median, if if n is odd, is not equal to 0, if n is odd, we are simply going to return the number at index mid, and we end there. Return ARR at index mid. So I'm going to now say else. So it's going to be else here. Else, if this is even, then the median is going to be the number here. So you have the number here minus the number here. So in this case, let's assume that this array has even number of items. So let me add 3 at this point. So the floor division is going to give us the median at this point is going to give us 4, which is I is equal to 4. You have 0, 1, 2, 3, 4. So here is going to be the median in this case. And that's going to mean that the median now, in this case, is made up of 2 items together. So in this case, we have the median to be these 2 items. And that is item at position mid plus item at position mid minus 1 all over 2. So I'm going to say return item at position mid, which is ARR mid, plus ARR mid minus 1 divided by 2. So this is a function to calculate the median of any given array. So remember, this is not the problem we are trying to solve. The problem we are trying to solve is this. So given an array, so I don't know, I think I'm moving out from the board. So given an array, array that is not like this, but array that is made up of values and their frequencies. So you have values is equal to 1, 2, 3, and frequencies. So given something like this, how do you find the median of this array? But that's not just what we want to do. We want to find the interquartile range. So we're going to divide this array into 2, find the median of the lower part, find the median of the upper side, and then subtract the median of the upper side, which is Q3, minus the median of the lower side, which is Q1. So the first thing you want to do is to destructure this array into one-dimensional array like this. To do this, you can simply use a loop to do it. And now I'm not going to continue writing on my whiteboard, but I'm going to now go to the Python, go to the HackerRank code window, and let's write it out there using Python syntax. And that simply solves the problem. But before I do that, once you destructure this array into this path, you are now going to calculate the starting point, because you need this time 2 Qs. For array 1, for ARR1, you have the start to be 0 and the stop to be, which is this item here, which is n over 2. And of course, you also have your n to be the length of this array right here. So let's now go to HackerRank and then solve this problem. While I'm writing the code, I'm going to be explaining it to you, and you see that it's going to be really clear. So stay with me and let's do this together and let's see how it plays out. So let's go ahead to solve this problem right now. So the key thing is that when you have these values and these frequencies given here, we want to actually flatten them into one array. That is one thing we need to do, and that's all the most difficult part of this challenge. So the first thing I'm going to do here, I'm going to write the helper function I told you. I'm going to write the helper function. I'm going to write it somewhere here. So I'm going to say def. I'm going to say get median, because we're going to use this helper function a number of times. So get median takes let's say let's call it AR. And so the first thing we want to calculate is the median to be the integer division of the length of the array over 2. So I'm going to say median is equal to length of the array over 2. So this is going to give us an integer value regardless of this, whether this number is even or odd. And we're going to check now if the length of the array is even. Yeah, so I'm going to say if length of the array is even, is equal to length of the array by mod 2 is equal to 0, and else. Okay, so in the case of when it is not equal to 0, that it means that it is odd, and it means that we simply return the middle, the value of the middle index. So it's going to be AR mid, all right? However, if it is not odd and it's even, then we are going to return the average of the two values at the midpoint. So I'm going to return I'm going to say ARR mid plus AR mid minus 1 divided by 2, and that's what we have here. All right, so this is our helper function. It's going to give us the median anytime we want it to. Okay, so the next thing I'm going to do now, we are going to now use this to solve this problem. Remember, I want to calculate Q1 and Q2. All right, so we want to flatten these values and these frequencies into one single array. So we are going to, for each of these values, we are going to repeat it the number of times it occurs in the frequency. So I'm going to use a little Python syntax. First, let me initialize an array. ARR is equal to an empty array. So I'm going to loop for A, B in zip. So I'm going to be zipping across these two sets of values at the same time. So it's going to be values and their frequencies. Okay, values and their frequencies. And now for each of the value, I'm going to insert into the array 3 times. So I'm going to say for I in range, the frequency which is looping through B, right? Let's give me a second. For I in range, so I mixed it up. So I actually wanted to put the frequencies here and the values here. So for I in range of the frequency, so in case frequency is 3, for each of those 3 times it appears, I'm going to insert this value, the current value of the value into the empty array. So I'm going to say ARR.append and append the current value of the array, which is B, which of course, this is what we are currently at. So we are going to insert it 3 times for each of the value. We have frequency, we're going to insert it I times, where I is simply the number of times it appears. Okay, I think you can just take some time to get your head around it. Give me 1 second, let me check what's... Okay, so I have a typo here. It's going to be square brackets, so sometimes this happens. All right, now we have flattened this array, and this is what we have, ARR. And the next thing we want to do is to sort this array. So it's going to be ARR the sort. Now I told you that before you can do this, you always, before you can calculate the quartiles or the medians, you always have to sort your array. Now, if I sort this array here, this is fine, but once I sort it here is also fine. It means once I'm calling the median function, I'm giving it a sorted array. All right, so let's calculate the start and the stop. So I'm going to say the starting point, so it's going to be start is equal to 0, and the stopping point is equal to ARR is going to be len ARR over 2. So it's going to be the same midpoint we normally calculate using floor division or integer division like this. So the first set of items, if you move from ARR0 to ARR len over 2 to this point, it means that we can calculate, we can get the median of that point. So I'm going to simply say Q1, which is the median of the first, which is the first quartile, now becomes get median, and I simply give it ARR slicing from starting point to the stopping point. All right. So at this point we have our Q1. Okay. Now, if you have our Q1 from at this point, we are going to now calculate Q2. Now, Q1 is stopping at the point, at the midpoint, right? Is stopping at the midpoint. The next item in line is the item in the middle. Now, if this item in the middle comes in a situation where the length of the array is odd, then we're going to skip it. So it means that we're also going to check if the length of this array is odd or even. So I'm going to check if length of this array, this time is length of ARR, is odd or even. So I'm going to start with checking if it's even. If it's even, we simply determine that the stopping point at this point will be the length of the array, while the starting point will be the stop position here, which is here, right? So as I was saying, if the length of this array is even, the starting point will be of the second array. The starting point of the second array will be this top position here. Remember when we calculated Q1 and we are using this slice operator and we're having start to stop, this is going to slice from 0 to a number before stop. So if we have an array of length 8, it means that it's going to go from, we have calculated our stop to before, so it's going to go from 0 to 3. And in this case, we are now going to go from 4 to the end of the array. So we are going to calculate Q3 to be equal to get median, and we are going to give ARR from stop, this time from stop to the end of the array. So it's going to be like this, okay? And else, so else Q3 will be get median. This time we are going to jump one item from here. So it's going to be wait 1 second, yeah, median, and we are going to go ARR going from it's going to be stop plus 1, stop plus 1, because we are going to jump one item because this time is odd, and we are going to go second, stop plus 1, slice into the length of the array. Okay, so let me just shift this one here. All right, so this is what we have at this point, and we are going to simply calculate Q3 minus Q1 and return the result. So I'm going to say results is equal to Q3 minus Q1. But now they want the result to be a floating point number, so I'm going to just convert it to a float before I return it. So I'm going to just convert it to float, and I'm going to simply return it, and I'm going to round it off to round the results off to 1 decimal place like this. So this is how to solve this problem, but we are going to check whether it works before we celebrate. So I'm running it right now, and it tells us list must be integers, not slices. Yeah, so this case we need to have a column here and not a comma. So I think that's the problem. So I'm going to run this code again and let's see if it works. Yeah, so it requires that we print it out, I think. So it's not just to return it, we are simply going to print it out to the output. So let's run again and let's see what we have. And this time it passes the sample test case 0. I'm going to submit and let's see what we have. And you can see that it passes all the 5 test cases. And I'm going to be stopping here, but I'd like to thank you for viewing. Remember to subscribe to my channel. And please leave me a comment if this has been informative for you. I remain kind on the genius, and I'm always there for you.